Hello everyone. Today in this video we will be discussing the first module of Automata and Theory of Computation. This subject is the hardest one among all the other subjects in our current semester, 5th semester, and this module has a lot of topics which are mostly theoretical. So what I did is I will be selecting the topics. I have selected the topics which are mostly asked in exams. From the exam point of view, this video is for, okay. So this is not the whole syllabus, it's not even a part of syllabus, but in exam they ask from these topics only, okay. So we'll be discussing these topics in depth. So the first one is the basics, what is the alphabet, string and language, and then we'll move on to the problems, okay. And before starting, if you like this video, hit the like button, and don't forget to subscribe to my channel, okay. So let's get started with the basics of Automata and Theory of Computation. The basics are mainly you need to know the three things: alphabet, strings and languages, okay. What is an alphabet? An alphabet is a finite set of symbols denoted by sigma, okay. So sigma is equal to ABCD I have written here. So these are the alphabets. If you say X, Y, Z, those are also the alphabets only, okay. That can be included here. And you can have the symbols like the alphabets as the symbols also, like star, heart or square. These are also the alphabets, okay. And you can have numbers also, 0, 1, 2. So the single symbol is known as an alphabet. And coming to the strings, string is a combination of alphabets, okay. For example, we have the alphabets here, A, B, C and D. The string can be any combination of A, B, C, D. A can be a string, A, B, B, A, any combination of these letters, okay, and any length, okay. That's what's the definition of a string. After that, we have some functions on strings, like what is the length of string. Length of this string is 7 because it has 7 alphabets. Length of this string is 3, okay. And coming to frequency, it's denoted by the letter which is repeated in this string. For example, if I write hash B and I have written this string here, how many times B have occurred in this string, that one will be finding out. B has occurred here, here and here. So the frequency of B in this string is 3, okay. Okay, so that's about the frequency. And replication means we are repeating the same symbol another time, okay. So see here, W of I plus 1 can be written as W into W of I. Like in max you write no x square into x cube, that will write as x power 5, okay. This will be adding. Same thing here also will be adding. I plus 1 can be written as 1 plus I. And W power 0, if the string is of no length, it will be denoted by epsilon. Epsilon is an empty string. For example, if I write A cube, we will write as A, and by square, by, and A power 0, B power 3, B cube. B will be repeated 3 times, okay. That's the replication. Coming to reverse, it's denoted by W raised to R. If you have to find out the reverse of any string, for example, if W is ABCD, if you have to find the reverse of it, what I will do is I will divide into 2 parts, okay. These 3 letters will be denoted by U, this letter will be denoted by A. A will be the last letter, okay, and I will be shifting this letter in the first position and writing this here. So what I will get is D and ABC's reverse. What is ABC's reverse? C I will be writing here and AB's reverse. B I will be writing here and A reverse. A I will be writing here. So I will get finally as DCBA. That's the reverse of ABCD. Coming to languages, it's a set of strings. What is a string? String is nothing but A, B or B, A, C, D, like that, okay. This set is known as language, alright. So we have an example here. In the exam you can expect this type of question. They will ask you to construct any language and you will be given with this statement. Now what's this statement? W belongs to A comma B whole star, and colon we have here, and the condition is string of length 2. So we have to form a string of length 2 using the alphabets A and B. So there can be 4 combinations: AA, AB, BA and BB, okay. These are the strings formed using the alphabets A and B, and the condition is it should have the length 2. If they tell me to find the length with 3, what I will do is AAA, AAB, ABA, BAA, like that I will be writing how many combinations will be formed, okay. So that's a language, a set of strings, okay. Now after knowing the basics, let's get started with the type of questions you can expect in exam, okay. So we have the main topic, which is FSM, finite state machine, okay. This you might know, in the last year we had studied finite state machine, and even if you do not know, we will be discussing now. So, what is a finite state machine? In finite state machine, basically we will have two or more states. Okay. So, for example, if a person is hungry, okay, and the second state is eating, the person is eating. The third state is the person is playing. Okay. So, when a person is hungry, he will go to eat. The next is after a person gets over with eating, he will play. When he plays, he will become hungry. Okay. So, these are the states. This is state 1, this is state 2, and this is state 3. These are the transitions, okay, from one state to another state, and based on a condition, the person is hungry, so he will go to eat. He has finished eating, so he will go to play, and since he has played, he will become hungry. Like that, many combinations will be there. Okay. So, this is known as state diagram or finite state machine. Okay. So, we have two types, deterministic and non-deterministic. In deterministic, we will have the transition from one state to one state. In non-deterministic, we will have the transition from one state to two or more states. Okay. That is the only difference. For the same input, we will have the transition to two different states. Okay. So, first we will be discussing the questions under this topic, then this topic. Okay. So, let us get started with DFSM, deterministic finite state machine. Okay. So, this is defined by these 5 symbols which we will be discussing now, and these are the rules and these are the questions. Okay. So, you can expect a question of this type. The first question is, draw a DFSM or DFA also, you can call it as DFA also, deterministic finite automata. Okay. To accept a string of A's having at least one A. Okay. So, the thing is, we have to accept a string of A's, means in that only A should be there, and at least one A should be there in that set. So, the possible combinations are, before that what is the letters used, only A is used. So, this denotes the set of letters. Okay. This is the letters which are used. Okay. So, only A will be there. And what are the possible strings which can form? A, this is the least one, at least one A should be there, AA, triple A, 4A, like that we can go on till infinite. Okay. So, this is nothing but DFSM's language. Okay. The language consists of these strings. These are the possible strings. Now, we have to construct DFA or DFSM. How we will do that? The first step is, what is the minimum string which we formed? The minimum one is at least one A should be there. Therefore, this is the minimum one. If we have one letter in the minimum one, we will have two states. Okay. Two states, state 1 and state 2. Okay. This is the starting state and this is the ending state. Starting state will be mentioned as an arrow and a circle. Okay. Arrow and a circle means starting state. Okay. Ending state means double circle. Okay. This is not included here, double circle. So, the starting state will be this one, ending state will be double circle. Okay. Since we have only one letter in the minimum string, we will have two states. If one minimum is there, we will have two strings. If the minimum was, suppose they had asked at least 2A. Okay. If the question was at least 2A should be there. So, this will be the minimum, right? This is the minimum. Now, we have two letters here. Therefore, how many states we will have? We will have 3 states. One is the starting one is the starting state, and another is the ending state. This is the intermediate state. Okay. Like that, how many letters are there? Plus 1, that many number of states. Okay. So, after making the states, write there as Q0 and Q1. You can write any denotation there, like any letter you can write here, Q0 or X0, like A0, A or B, 1 or 0, anything you can write. Okay. But mostly we use Q0 and Q1. Okay. So, these are the starting and ending state, and after that what we have to do is make an arrow. Okay. After we have made the starting and ending state, this is the starting, this is the ending. Okay. This is not there now. Now, what is the letters which we have? Only A we have, right? So, therefore, write here A. So, this is the starting state. If I go through this state, what is the string I am getting? A. But what is the condition here? We have to accept more number of strings, like at least one A should be there, but we can have more number of A's also. So, for that also we have to make some arrangement. How we will do that? The first is at least one A should be there, and after that if further more A's are there, what we will do is we will do a self loop. So, if I have to get the loop AA, what is the flow of the path? A from here, and then due to this A, again it will come to the final state. If I want another A, I will go through this loop again. Okay. If you do not understand now, it is alright, because we will be solving many questions. Hopefully you will get to know the actual concept. Okay. So, in that way we solve. First what we do, how many letters are used, what are the possible strings which we can form, find out the least string. If there is one letter in it, make two states and make a connection, write there that letter here, and then if you want more strings, make the specific changes in that. Okay. And what is q? Q is the set of states. So, here we have two states, q0 and q1. So, q will have here q0 and q1. Okay. And this is the transition function. In transition function we have, if we transition from q0 upon a, where we will reach, see here, q0 upon a, where we will reach q1. So, what I have written here is q1. Okay, q0 upon a is q1. The next one is q1 upon a. From q1, if I go through a, where I will reach q1 only, because it is a self loop. So, this is the transition function, and after that we have to write the starting state and the accepting state or the final state. Okay. Starting is from q0, ending is to q1. Okay. And the transition diagram is made looking at the transitive function. See here, q0 and q1 are the states. See, initial states are q0 and q1. These are two states, q0 and q1. After that, passing through a, q0 to a is q1. So, we will write here q1, and if you are in q1 and if you travel through a, where you will reach, again q1 only. Okay. So, that is the transition diagram. Moving on to the second question, we have been asked to draw DFSM to accept a strings of A's and B's having at least one A. Okay. In the previous one we had only A here, now we have A and B also. Okay. So, let us see how to do that. First, write the letters used, A and B. Okay, A and B, and what is the minimum language you can form? The condition is having at least one A. For B they have not mentioned anything like compulsory or not, therefore we can avoid that. At least one A means only one A will also be acceptable. So, this is the minimum one. This is the minimum length of string. If there is one letter in the minimum one, we have to make two states, q0 and q1, and make a transition, write whatever the alphabet is here. Okay. After that we have B also. So, we have to make the arrangement for B also. What if the first letter is B? Okay. What will happen if we are in q0 and B will be the input? Okay. If B is the input, we cannot go to the final state. This is the starting state, this is the final state. If B is the input, we cannot go to the final state, because before going to the final state, what we need to make sure is it has at least one A. If we make a direct connection here and write B also, what will happen? It will accept B, but this is the wrong string which we do not want to include in our language. Okay. So, therefore, what I will do is I will make a self loop. That is the first rule. First rule, you have to see if a self loop can be made or not. Okay. See here, I have written the rules here. While constructing the FSM, check for self loop. Okay. For whatever the input is, check for self loop, then check the nearest states, then go for dead state. Okay. We will be discussing each of these in detail by using some examples. Okay. So, go for the self loop. The first thing which you need to say is the self loop. We can go with the self loop because the condition is only at least one A should be there. After going to the self loop, I can have n number of B's like B, 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 then finally we will before reaching to the final state, we will pass through A. So, therefore, my language will have always at least one A. Okay. So, for Q0, the A's transition is done, and from Q0 B's transition is also done, and Q1 is still empty now. Means if we reach Q1, and after that what? Q1 is the final state, and after that also if some input comes, what should happen? If A comes, where should I go? If A comes, check for the self loop. If A comes, I can go to the self loop, yes, because at least one A should be there, that is only the condition. See here, at least one A should be there, that one A is passed here. Before reaching to this, I have at least one A. So, therefore, whatever the string will be there after that, it does not matter. Okay. So, I can have self loop for both A and B. Okay. Both A and B I can have self loop. Okay. After writing this, write down the Q set, write down the set Q, which is Q0 and Q1, the states used here, and the transition function. In transition function what we have is from q0 to a, q0 to b. Okay, from q0 a and b, what is the answer? From q1 a and b, what is the answer? We will look at here. From q0 to a, what is the answer? q1. So we will write from q0 to a, the answer is q1. And from q0 to b, from q0 to b again I am reaching q0 only. So therefore I will write here q0. Same thing for q1 also, q1 to a the self loop q1, q1 to b the self loop q1. Okay. So this is the transition function. By looking at this, make the transition table also. q0 to a, what is the thing? q0 to b, what is the thing? Same thing for q1 also. Okay. After making this, write down the starting state and starting and the accepting state. q0 is the starting one and q1 is the ending one. Okay. Let's discuss the third question now. What they have asked here. Draw a DFSM to accept strings of A's and B's. So we have two alphabets here, A and B, having exactly one A. Okay. So in the string which we form, there should be only one A and any number of B's can be there. Okay. So what's the least string which we can form using the alphabets A and B? The least string is A. Okay, because exactly one A is only there and they have not told anything about B, right? So other strings are A B, A B B, A triple B, because A cannot be repeated further. So we don't find any A after this A. After this A, we cannot find any A after that. Okay. So the least string is A only, which is having only one alphabet. Therefore, we will have two states. Here we have two states. This I will read over here. The state 1 is q0 and the state 2 is q1. This is the starting state and this is the ending state, and here I will write A. Okay. After that we have two alphabets, so we will have to consider two alphabets for each state. From this state and from this state, what are the alphabets I have to consider? A is done from this state and B. If I am in this state and if B comes, what I have to do? I can first have to check for self loop. If I form self loop, what are the combinations which I can form then? B, B, n number of B's followed by a. The condition is exactly one A should be there, and that is getting fulfilled here. Therefore, this is a valid loop. Next, A and B is done for this one. We will go for A and B for this one. Since already one A is done before reaching this state, if I am in this state now, 2A will be included. That should not happen, right? So A will go to dead state. Dead state means it has not reached the end, but it has reached the invalid space. Okay, that string cannot be accepted like that. Okay. A. What about B? If I am here, I can accept n number of B's, right? That will not make any difference, because if I go here A, then I can go for n number of B's, B, 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 B. Then I can either stay in the final state or go to the dead state. If I go to the dead state, that's an invalid string. So I will remain in the final state, which is A followed by n number of B's. That's a valid string according to the question. A and B string we have found, which is having exactly one A. Okay, and this is the Q. This is the transition function. Based on that, we have written the transition table and starting and ending states. Okay. In this question, we have been asked to accept the strings of A's and B's starting with AB. So starting should be AB. That's a condition. What is the minimum string which we can form? AB, right? AB is a valid string because it starts from AB, and after that we can either have or not have, that upon our own wish. So this is the minimum string AB. It has two alphabets. Therefore, how many states we will have? We will have 3 states, right? Because if minimum is 2, we will have 3 states. 3 states we have. Make the arrows, write A and B here. See here, what I did is I made 3 states, Q1, Q2, Q3, and I wrote A and B. A and B because the minimum string is AB. So I will write A here and B here. Alright, and after that we have this starting state and this ending state, and we will consider for each state both the alphabets A and B. Okay, the alphabet set is A and B. Therefore, for each state I have to see what is the state transition for each letter A and B. So for Q1, what is the transition with A? Q1 upon A is Q2. That's done. Q1 upon B. Go for self loop. If I go for self loop, it will be starting from B. See, if I include self loop for B, what will be the combination before reaching final state? B, n number of B's, then A B, B B, like for example A B. This is an invalid string. Why? Because the string should start from A B. Therefore, in starting I cannot have B. What about going to other parts? That also I cannot do because I have to start from A only. Therefore, I will go to dead state. Okay, B will be going to dead state. Okay. What about the second one? While I am here, if B is done, what about A? If I include A here like self loop, what will be the starting string? A, n number of A's followed by B. This is an invalid string because it should start from A B. Okay. So, I cannot include this one, therefore, I will go to dead state. A will be going here, and here n number of A's and B's will be remaining in the dead state only. This is the invalid strings. Okay. And after that we can have here A B. After it after the starting letter is A and B, I can have n number of A's and B's, that does not matter. Okay, because the condition is what? The condition is starting with A B, right. So, starting with A B will be here, and here we will have n number of A B's. Okay, that will not make any difference. That will not make any difference. Okay. So, for each state we have the path for A and B. Our FSM is done, and after that we will write the states here and the transition function, transition diagram and starting and accepting states. Okay. The next question is to draw DFSM to accept the strings of A's and B's and ending with ABB. So, the last in the string whatever we choose, in the last there should be ABB. So, let us see how to do that. What is the minimum string you can form? ABB only, right. Here we have 3 letters, therefore, we will have how many states? 4 states. I will make 4 states and I will write, I will make the arrows here, I will write A, B, B. That is our initial steps. Okay. After that for each state you have to check the path for A and B. The condition is ending with ABB. Remember this one while drawing the other states. Okay. Now I am in Q naught, I will have for A I have here, what about B? Check for the self loop. If I make any self loop, does that make any difference with the condition? In this I can have the string as B, then A, B, 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 A, B, B, n number of B's followed by A, B, B. At last I am getting this one. So, therefore, self loop is a valid one. Same thing we will do for Q1 also. In Q1 I have for B, what about A? Ending should be ABB, right. If I have n number of A's here, a self loop, what will be the string? If I have suppose B, A, then n number of A's followed by B, B, means n number of A's will be there followed by B, B. So, anyway I will get in ending ABB. Therefore, self loop is valid for Q1 also. What about Q2? In Q2 it is between B and B. So, B, if I have self loop here for A, then it will be BAB, it is a wrong one. So, I should get BB only at last. So, I cannot have a self loop. So, I should check the nearest neighbor. The nearest neighbor is Q1. Okay. So, Q1 I can form A. So, it will go here, like what will be the string then? For example, the first one will be A, then B, then again if A is there it will go here, then again it will go B, B. So, see here what is the thing formed? A, then it went to B, then it went to again A, then from here again it came to B, then it came to B. So, it is ending with ABB. Okay, in that way we will find out. Same thing we will do for Q3 also. In Q3 we have to find out for both A and B. The self loop is not possible because it will end with A if I make a self loop for A, or if I have to go here, if I choose A here, it will be BAB, that is a wrong string. So, I have to go for here. Then for B also I should go for here. Okay. I cannot go for here because B is there. Then again if I go for B here, then it will be BB, then this B will come triple B. Its ending with triple B is a wrong string. Alright. So, in that way B should be going here. So, therefore, it will be same as this self loop. Okay. So, check for the self loop, or else check for the nearest neighbor, or else go for the dead state. Okay. So, in that way we will be solving the questions. Here write the Q state and the transition function and the starting and the ending states and the transition table. Okay, I have not filled here, but the thing is you got the point, right. So, that is what I have aimed in this video to give you the point. Okay. Question which is draw DFSM for to accept the strings of A's and B's having substring AAB. So, here it is not mentioned like starting or ending, anywhere you can have, but AAB should be there. Okay. So, let us see how to make that. what is the minimum string you can form? The minimum string which you can form is AAB only, because that is a substring. Okay. So, this is included, AAB is a minimum one, 3 letters, 4 states, make the connections, write AAB, then for each of the state check the path for A and B. A is there, B can form a self loop, yes, like that check for all the other loops also. So, this is the state diagram which you get finally. Okay. Same thing for here also, to accept a strings of zeros and ones with 3 consecutive zeros. Here what is the minimum string which you can form? 0 0 0, right, 3 states, 3 letters, 4 states, then 0 0 0, that is the initial step which you have to do. After that check for 1 also, because we have 1 also, 1 can form a self loop, here also 1 can go here, in between 1 cannot come because consecutive zeros. Okay. In that way you have to check and make the all the combinations. Okay. Then draw DFSM for the strings of A's and B's which do not end with AAB, do not end with ABB. See, till now we are doing for ending with some particular pattern. Now we have to do for not ending with a particular pattern. It's very simple. What we have to do is we have to make the same thing ending with ABB. Like in the previous question we did, right, ending with ABB, that is the same diagram we will make here. Okay. So, see previously where we did here, that end with ABB. See here which was that question. See here, ending with ABB, this is the diagram which we make, that this is the first step you have to make if they ask for not ending also. Okay. After making this one, just change this final state to other states. Okay. These 3 will become final states and this will become the starting state. See here, this is the same diagram here, ending with ABB, and change the states, so that we will get all these states will become final state, double circle, and here we will have single circle. Okay. Everything will be same, only the state will change. Okay. Double circle will be shifted from here to these 3. Okay. So, this is not ending with ABB. If you have to see, we can confirm. See here, this is the final state. Okay. If I go with A, B, B, it will go here again. Again I have to go to here or here, then only I will reach the final. So, therefore, anyway I will end with A or B, but not with ABB. Okay. That is the thing for not ending with any pattern. Okay. Which is to draw DFSM to accept the strings of A's and B's. Okay. So, A's and B's are the alphabets and the language is AWA. What does AWA mean? AWA means starting with A and ending with A, and in between you can have W, and W can be any combination of A's and B's. Okay. So, what is the minimum string we can form? There should be starting with A and ending with A, in between we can have empty also, therefore, the minimum string will be AA, right. So, AA, if it is a minimum string, we will have 3 states here and we will write here A and A. Okay. After that we will see for each state we need to have A and B. Here we have from A, and from B what's the thing, if we have any self loop from B, the string will start from B then A and all, so it is a wrong string. So, therefore, B should go to dead state. And coming to here also we can have any A or B's, so therefore, we will have a self loop here for B. And coming to final state, after it ends with A, it should end with A, so we will have a self loop, and if there is a B, it should go to here. Okay. Because if we end with B like a self loop, it will end with B, that string should not be accepted, right. So, we will not be accepting that and going on with B to here. So, therefore, B will be coming in this place, and after that finally it will end with A, and starting is also A. Okay. The next question is draw DFSM to accept zeros and ones. So, the alphabets are 0 and 1 for the given language. The language is, it starts from 0 0 and ends with 1 1, and in between we can have any combination of 0 and 1. Okay. So, what is the minimum string we can form? 0 0 1 1. We are avoiding this one, we can have empty also, therefore, the minimum is 0 0 1 1. We will have 5 states here, and for each state we will calculate if it is a self loop or other loops to the other points, or it is a dead state. Okay. For each zeros and ones. Draw DFSM to accept a strings of A's and B's having 4 A's. So, here it is not mentioned we should have in the starting, middle or end. Okay. It should have just 4 A's, and it is not necessary that it should be consecutive. Okay. It can be anywhere. So, what is the minimum string we can form? 4 A's. So, we will write here 4A, and in between we can have any number of B's. So, because it is not compulsory that A should be consecutive, therefore, we will have this string here with self loop of B and A's connected together. In the final state also we can have n number of A's and B's. Okay. Because already 4 A's are included here, therefore, in the final state we can have n number of A's and B's. Draw DFSM to accept the strings of zeros and ones and twos. So here we have 3 alphabets 1, 0, 1 and 2. Okay, and beginning with 0, so 0 should be the beginning, followed by odd number of ones and ending with 2. So in between we can have odd number of ones. Okay, that's the thing. What's the minimum string? 0, 1, 2. So the number of states will be 4 and we'll have 0, 1 and 2, and then we'll be checking for each. It should have n number of odd number of ones. So if it should have odd number of ones, what's the rule we have to apply? See here, if it's starting from 0, then 1, again we have to come here if it's 1, because if we go to the final state after 1, it will be wrong string, because it will be 1, 1, 2. Okay, that should not be accepted. Therefore we will come back to here. If 1, 1, 2, then again it should pass through here, so it will become odd number. If it's even number, again it will come here and go here, so it will become odd number. Therefore this will ensure that there are odd number of ones, and same thing for ending with 2 and ending with 0. If at the end point we have 0, 1, 2, it should come to the dead state, because it should be ended with only single 2. If any other 2 comes, it should go to dead state. And same is the thing for starting with 0, only it should start with 0. If it's 1 and 2 is in the starting, it should go to dead state. Okay, that's the thing. Okay, and in this state what we have is, if it's 0 or 2, it should be only 1 in between. So if 0 and 2 are there, that will also come to dead state. The next question is to construct a DFA which accepts a language of all binary strings divisible by 3 or by 3. Okay, so there should be the strings which are divisible by 3. Now see, this is 0. Is 0 divisible by 3? Yes. 1 is divisible by 3? No. What's the remainder? 1. 2, the remainder is 2. 3 is divisible by 3. 4 is not divisible by 3, the remainder is 1. So what we can observe? What are the reminders which we get? Here we get the remainder 0, okay, and 1 and 2. So these are the 3 possible reminders when we divide by 3. Therefore our first step is to write down the reminders. Okay, reminders are 0, 1 and 2. And how many states we should make? Whenever you get a question like for divisibility, you should make only one state, which is a starting and final state also. Okay, so I'll make the states here again. This is Q naught, this is the starting and final state. Okay, now if 0 is there, 0 is divisible by 3, so therefore we will have the self proof for 0. Okay, what about if the remainder is 1? If the remainder is 1, it should come to the state Q1, which is the remainder 1. Okay, so here we will have 0, 1. So 0, 1 is nothing but 1. Okay, and what about 2? What is the binary equivalent of 2? 0, 1, 0. If the remainder is 0, 1, 0, it should come to the Q2 state. Okay, these are 3 states, because there are 3 possible remainders, we will have 3 states. Okay, and what will be the number here? The number here will be 0, 1, and for 2 what is the binary code? 0, 1, 0. So therefore we will have 0 here. Okay, that's the same thing I mentioned here. First 0 for no remainder, for 1 remainder, for 2 remainder. 0, 1, 0 for this one, and 0 and 1 for this one, and 0 for this one. Okay, after doing that we have to set for each state zeros and ones. Okay, so how to do that? Here if it's 4, what will be the number? It will be 0, 1, 1. Okay, see 0, 1, 1 is the binary equivalent of 4. If the number given is 4, then what we have to do is 0, 1, 1. Okay, what will be the remainder of 4? 1. That means Q1 should be the state. Okay, if it's 4, it should end at Q1. So how we will do that? 0 is here, then 1, and it should end with Q1 only, right? But it's not ending at Q1, it's going back to Q naught, because one mistake, the binary equivalent of 4 is not 0, 1, 1, it's 3. So therefore the 3 is ending here. What about 4? 4 is not 0, 1, 1, it's 1, 0, 0. Okay, so what if it's 1, 0, 0? For 1 we have defined already, it goes to here Q1 and 0, 0. Okay, 1, 0 we have defined, it will go to here, and again 0. If it's again 0, what will be the remainder? 1. For 4 it is 1, right? So it should come back to Q1. Okay, what about 5? The binary equivalent of 5 is 1, 0, 1. 1, 0, and 1 again I have to do. In 5 what will be the remainder? Remainder is 2 when I divide by 3. So therefore it should end at Q2. So 1 will be self loop here. 1, 0, 1. Okay, in that we will check for all possibilities, and until for each state 1 and 0 have been filled, we will be doing the same thing. Okay, this is same, the steps are same for any divisibility like 3, 5, 7, 8 like that. Any type of divisibility question you have to do the same steps. Okay, the next question is to construct a DFA such that the string which is defined as this has the length mod 3 is equal to 0. length mod 3 is equal to 0 means what? The number of A's, okay, only it should have A and the number of A should be a multiple of 3, okay. So, the least string which we can have is AAA, next we can have AAA, and in between we can have B also, okay. So, the least string is AAA, so we will have A, finally it should come to this state, okay. So, therefore, we will have 3 A's, only if 3 A will be there it will come to this state. Suppose that the string is AABB, where it will end? A, then B, self loop, again self loop B. So, it will end at Q2, it will not end at Q0. Why? Because only 2 A is there. If I add another A, then only it will come to this state, okay. Due to this A, it will come to final state. Here we have 3 A's, okay. Next question is to obtain a DFA to accept a string of W satisfying the following condition. Our next question is to obtain a DFA to accept a string W satisfying the following condition. What is the condition? W mod 3 is greater than or equal to W mod 2. See, if they give 2 mods in one question, what we have to do is, we have to write down the alphabets. See, in the alphabets what we have is A, it is given in the question, W is belongs to the alphabet set A, okay. So, what are the possible states? W mod 3 and W mod 2, that means the remainders can be 0, 1 and 2 for mod 3, and for mod 2 these 2 are remainders. Overall we have 3 types of reminders, okay. So, we will have 3 states, we will make 3 states here, one for mod 3 and one for mod 2, okay, like a previous question how we did, and after that what we will do is we will merge both of them, okay. We will do M1 into M2. Now, see here, the remainders in W2 means M2 are 0 and 1, the remainders here are 0, 1, 2. We will make a combination of each of these, 0, 0 we have written here, 0, 1 we have written here. Same thing we will do for 1, 0, 1, 1 and 2, 0, 2, 1, okay. After writing that, we will make the transition table. Since the alphabet is only A, we will write here A, and PQ is nothing but the state of M1 and M2, okay. So, we will write here 0, 0, the first state here 0, 0, 0, 0 upon A is what? For M1 and M2, when it is 0, 0 upon A is 1, okay. For M1 it is 1, for M2 it is 0 upon A is 1. So, therefore, we will write 1, 1 under this table, okay, 1, 1. For M1 it is 1, M2 it is 1. Now, what is the next state? 0 and 1, okay. For 0 and 1 upon A, what is the thing? 0 upon A is this one 1. So, from M1 it is 1, and what about M2? From 1 it is 0. So, 1 comma 0 will be written here, okay, 1 comma 0. Like that we will do for all the states, and we will write here, okay, the combination, and after this we will make the transition diagram, okay. These all states 0, 0, from 0, 0 it going to 1, 1, from 1, 1 it will go to 2, 0, from 2, 0 it will go to 1, 0, 1 and so on, okay. In that way we will write here 0, 0 to 1, 1, then 2, 0, 0, 1, 1, 0 and 2, 1. After making a single circle for every one, we will have to see which are the final states. What is final state? Final state means, see here, in this the final state is this one and this one, that means this is 0, this is also 0, Q0 and Q0. Therefore, 0, 0 where all it will be there, that is the final state. Or mod 3 is greater than mod 2, wherever the value of mod 3 will be greater than mod 2, like we write here, right, 0 and 0, this is greater than or equal to this one. So, therefore, it is a valid string and we will make double circle, okay. So, we will write here also the same thing, 0, 0 is a valid string greater than or equal to 1, 1, 2, 0, but 0, 1 is not greater than or equal to, so it will not make a double circle. Here it is greater, here also it is greater. Therefore, this is the transition diagram. In between we will write A's, and finally we will connect each of them, okay. Coming to non-deterministic finite state machine, it is a bit easier than the previous one. So, what is the thing is, we will here have 5 things, this we already know what are these things. And moving on to the questions, we have construct an NFA for the given language, string starts with A over A and B, okay. String should start with A and the alphabets are A and B, okay. After writing this, we will write here the states. What is the minimum string which we can form? The minimum string which we can form is A, okay. It should contain A, starts with A, and it can contain A and B. So, therefore, the minimum one is A. We will have 2 states here, and in each state we will write A, okay. After that, it is upon our wish if we have to include for B or not, okay. In DFSM we have to have each state determined, okay. Each state should have a result, but in non-deterministic it is not the case, we can either have or not have. So, therefore, in Q0 we need not check for A and B as we used to check for DFSM. Here if A is there, it's enough. Okay, for B we need not be concerned because it is NFA. Okay, and here finally we'll have A and B. Okay, because it's followed by any number of A's and B's. Okay, so here we'll have A and B. Construct an NFA for the given language, string end with A over A and B. So here also string ends with A. What is the minimum string we can form? A. Okay, so here we'll have two states and we'll write a arrow mark here and A. Okay, now string ends with A. If it ends with A, it can start with any letters A and B. Okay, and it should end with A, therefore A should have a self loop in the final state, and if it's B, again it should go to the starting state, because if we make a self loop for B, it will end with B. That should not happen. Okay, so I will make a arrow mark here, and it's totally upon you if you want to make this arrow mark, make, or else don't make, because it is NFA. Okay, all we need to do is satisfy the given condition, which is A, and we have already done, that. Okay. Next, construct an NFA for the given language. In this, we have string contains A over A and B. So it should just contain A. It's not mentioned that starting or ending. Same thing, we'll have two states here, and in between we'll have A. Our condition is satisfied. Either make this or not, it's upon you. Okay. Construct an NFA for the given language. A string starts with AB. Here we have starting AB. So the minimum string is AB. We'll have three states then, A and B. Now after that you can make for B here, or else if you want, or else if you don't want, you can skip it, as I have skipped here, but here I have made. Okay, here also you can skip. Okay, construct an NFA to accept the language. W belongs to AB raised to n. Okay, that means A B A, then n number of B's will be there. B raised to n means n number of B's. Okay, so this type of string we should form. What is the minimum string which we will form? They have given here or means we can have two states here, either this one or this one. So for that A B A and followed by n number of B's by self loop. This is one answer. If they give or here, another answer is A B then followed by n number of A's. Okay, this will be the two answer in NFA. The next type of question which could be asked is the conversion of NFA to DFA using the subset construction method. Here the language is given ending with A over the alphabets A and B. So the language should end with A and it can have the alphabets A and B. Okay, so we have to convert NFA to DFA. First we will make NFA then. Okay, so here we have the least minimum is A. We will have two states here followed by A, and in between we have A and B here for self loop, because it should end with A. Okay, and we have to transfer this into DFA. First we will make the transition table for NFA. Here we have Q0 and Q1 states, and the alphabets are A and B. Q0 upon A is Q1 Q2, because A is going here also and it can go here also. So we will write Q0 and Q1, and for B it is Q0, so we will write here Q0, and from Q1 we have no states through A and B, so therefore we will write here null. Okay, after making this we have to do the same thing for DFA also, but here what we will do is for each state we will take the union. What is the union of these two? It is Q1 Q2, therefore we will write here Q1 Q2. Here also we will write Q1 Q2 wherever it is null, and here also it is null, so we will take the union and we will write here Q0. Then after getting the transition table for DFA, we have to make the transition diagram. Okay, that's how, means the new states which we got is Q0 Q1 and Q0. Okay, so two states we have Q0 and Q0 Q1. This will be considered as a single state in DFA, and looking at the table, Q0 is the starting state and this is the ending state, and here we will have A. Q0 upon A is Q1 Q2, so I have made an arrow here. In the same way I will make the arrow for other one as well. Okay, and this is another concept, epsilon NFA. Epsilon NFA that accepts zeros or 0 or more A's followed by 0 or more B's followed by 0 or more C's. Okay, so what we can have is n number of A's followed by n number of B's followed by n number of C's. It can be 0 also. So there are few combinations here. Either B will be missing from here, either A will be missing, either C will be missing, or we can have null string, or only A, only B, only C, or a combination of three of these. Okay, so these are the possible states. So the minimum string which we can form is null. Okay, so we have to include null also here. With null also we can go here, means if you don't want to take A, what we have to do is we have to go through null. Here also we will go through null, we will reach the final state. After making this, we have to add the A's and B's and C's, because it's n number of A's followed by n number of B's followed by n number of C's. Okay, after making this we will make the transition diagram. We have three states here, Q1, Q0 and Q2. We will have A, B, C, and including epsilon here. We will see if we are in Q0, if we encounter A, where we will go Q0. So we will write here Q0. Q0 and B, if we don't have any path from B through q naught, so we will write here null. Therefore, we will do the same thing for all of these, and for epsilon also we will see here from q naught epsilon is equal to q1, we will write here q1. In the same we will fill the table, and this is the final answer for this question. Okay, we had to just construct the epsilon NFA table. Okay, and this is the diagram for epsilon NFA. In our next question, we have been asked to obtain an NFA to accept a language which consists of A and B is and the language is made up of optional A followed by double A. Okay, so initial A is optional, so I have to have this self loop for optional A followed by epsilon, because it's optional. If I want to skip, I have to have a path for skipping, right? So I'll mark arrow here with epsilon, so it will not take any string and move to q1. Followed by 2a means it should have 2 a's here, and after that I can have n number of b's. Okay, and looking at the table, looking at the diagram, we'll make this table, and this is the transition diagram followed by a transition table for this question. Okay, and one important concept which we need to know is conversion of epsilon NFA to DFA. Okay, so here we will have the combinations of epsilon also, we have to convert to DFA. Before that, we need to learn the concept of epsilon closure, how to do the epsilon closure. Here in this diagram we have q0, q1 and q2 and q3 also. This is the final state and this is the starting state. Now see here, we have to write the epsilon for each of these. What is the epsilon for q0? Epsilon for q0 means q0 is followed in epsilon to q1, q1 has epsilon to q2, q2 has epsilon to q0. So therefore the travel states through epsilon are q0, q1 and q2 if we start from q0. Therefore we have written this one. What about q1? If we start from q1, which all state we can go through epsilon? q0, q1 and q2. Okay, so we will write here q1, q2 and q0. Same thing for q0, q2 and q3 also. Okay, after writing that, we will do the further steps. This is a very important question from exam point of view. So how to do that? This is the given state here. We have to first write down the current state. Current state is a starting state, so we'll write here q0. Then we'll find the epsilon q0. Epsilon q0 means through epsilon I can go to q1 and q2 also. Therefore the epsilon will be q0, q1 and q2. Wherever we are starting from, that will have self loop also. Okay, means if epsilon self loop is not given also, it's understood that there is a self loop for epsilon also. Therefore in the epsilon q0 we will have q0, q1 and q2, and what we will do is we have got this new state now. Before only the current state was q0, now this is the new state which is q0, q1 and q2. Now we will see from q0, q1 and q2 through A, B and C. What are the alphabets given here? A, B and C. Therefore we will check for each of these. q0, q1 and q2 upon A means first check for q0 upon A, then q1 upon A, then q2 upon A, then write the three states. What is q0 upon A? q0 upon A is nothing but q0 only. So therefore I have written here q0. If I reach from q0 upon A, I will reach q0, but I can go to q1 without any other addition of new inputs. So I can go to q1 also, q2 also. Okay, so three states I will write here for this one, q0, q1 and q2. That's only for q0. Okay, from q0 I can travel to q0, then q1, then q2. Okay, so but I have to check for the q1 and q2 upon A. What is q1 upon A? It's not defined, so we will not write anything, and same thing for here also. Okay, so the only states which I got are q1, q0, q1 and q2 through A. Okay, from this I got the three states, other two are null. Okay, and same thing for the next one, q0, q1, q2 upon B. From B, where all I can reach? If I travel through B, like q0 upon B. What is q0 upon B? q0 cannot be travelled through B because there is no path through B, so this will be null. Okay, but what about q1 through B? q1 through B is q1 and q2. Okay, and q1 through C is null. Okay, so I'll have two paths here from q1 through B, which is q1 and q2. Therefore I'll write here q1 and q2. Same thing for C also. I just have the path q2, so I'll write here q2. Now which are the new states? This is the old state only. New states are this and this. So therefore I'll check for this and this also. Same thing I'll do. I'll check for A, B and C. Wherever I get null, I'll write the null. If I get a new state, I'll check for the new states also. After doing all that, we'll select those states and write here which are the states which we got. Here we got three states, q0, q1, q2, q1, q2 and q2. Now we'll select those states which have q2 in them as the final state. Why we are selecting q2? Because it is the final state. Okay, So therefore we will see which all states have Q2, this has and this has and this has. So therefore 3 are the final states. Now we will make the 3 diagrams here with double circle, and how to make these arrows. These arrows will be made as follows. For each circle we will see for A, B and C, means Q0, Q1, Q2. What is the path through A? Q1, Q0, Q1, Q2 through A we have written here already. Q0, Q1, Q2 through A is Q0, Q1, Q2. Same thing for B also we have written, C also we have written. That thing by looking at that we will make the arrow marks here, and we will do the same thing for both of these, and this ends the transition diagram for the given question. Let us look at one more question to understand more clearly how this works. Okay, in this question we have the variables 0 and 1, and we have 3 states here, Q0, Q1 and Q2, which is a starting state Q0. Now we have to check for 0 and 1 for both of these, like Q0 with 0 and Q0 with 1. What is Q0 with 0? It is given 2 states. Q0 is self loop with 0, also 0 with Q1. So therefore I will have Q0 with 0 as Q1, Q0 Q1, and Q0 with 1. In this diagram you can observe, if we are in Q0 and we have the input 1 where we are going Q1, therefore I will write here Q1. Now the active states are Q0, Q1 and Q1. We have 3 states now. This is the first state, this is the second, third. Same thing we will do here also. The only difference is we do not have epsilon here, so it is a bit easier than the previous one. We will form the new states and we will check for 0 and 1 for each of these states, and finally we will get the states and write here which all states have the final state, that we will double circle. Which all states have Q1 finally, which we get there, we will make as double circle, and the arrow marks are made by looking at these transition functions which I have written here, and we will make the arrows here. Okay. This is the last and the most important topic of this module, which is minimizing the given DFSM. Almost all the question papers have asked this type of question. Okay. So look, what are the steps? The steps will be the same, only the input values will change. Okay. So be clear with the steps. So starting we have this diagram given to us. In this diagram we have to divide into 2 parts. First is the normal and second is the final. In the normal we have the classes 1, 3, 5 and 6, because these are the normal states 1, 3, 5 and 6. 2 and 4 are final states, therefore we will separate them in a different class. Now we have 2 classes 2 and 4 and 1, 3, 5, 6. Okay. Now what we are supposed to do? How many variables we have? We have the variables A and B. Okay, only A and B. So the classes which we have written here, we will choose one by one. Okay, we will write here the first class 2 and 4 we are selecting. We will write here 2, 4 upon A, 2, 4 upon B. How we will do is, consider this example 2 upon A. Okay, this class we choose, we have two symbols here 2 and 4, we separate and write here, and upon A. What is 2 upon A? 2 upon A is given as 2 upon A 3. Which class 3 belongs to? 1, 3, 5, 6. So we will write here the class 1, 3, 5, 6. Same thing 4 comma A. Same thing for 4 comma A. 4 comma A belongs to which class? 4 upon A. A is this one, it is going to 6. 6 belongs to 1, 3, 5, 6. Therefore I will write here 1, 3, 5, 6. Same thing I will do for B also. If there is no split, means this should be same. Here also it should be same. Means both got 1, 3, 5, 6 here also and here also. So here we will have no split and here also no split. Okay, we will compare each of these variables. Okay, if there is no split, we will not do anything. We will keep the classes as such. Now let us take the next class, which is 1, 3, 5, 6. This was for this class, and now 1, 3, 5, 6 will be discussed here. Now for 1, 3, 5, 6 we will have 4 things 1, 3, 5 and 6 upon A. We will see 1 upon A is 2, so it is going to the class 2, 4. Therefore I will write here 2, 4. Same thing I will do for this all and this all also for the B. Then I will see which all are getting split. Divide into 2 parts and find here the groups. These are the groups 2, 4, 6 and separated by 1, 3, 5, 6. So there is a split here and here also there is a split. Therefore which class is getting split? 6. So therefore 1, 3, 5 will be separated as 1, 3, 5 and 6. So the new classes which we have are 2, 4, 1, 3, 5 and 6. The same thing we will do again. Take the first class upon A, see if there is a split. If there is a split, what we need to do is we have to separate the classes. 2 and 4 got split, so we will have 2 and 4 separately now. Okay, same thing here also for 1, 3, 5 and 6 also. Okay, after doing that, the classes are 2, 4, 1, 3, 5 and 6. In the step 3, we will see if there is no splits. If there is no splits, that is the final classes, and we will make the DFSM here. 135 will be considered as one class, 2, 6 and 4. Which will be the final states? Look at here, 2 and 4 will the final states, right, 2 and 4. So, therefore, whichever classes have 2 and 4, that will be considered as final states. 2 and 4 are in these two classes. So, therefore, those two are the final states. How to make the arrow diagrams? As I told before, we have to see these classes here, like we have written here, right. For example, 1 comma a goes to 2. So, therefore, if you are in 1 and it is going to a, it is going to 2. Okay. 1 upon a is 2, 3 upon a is also 2 and 5 upon a is also 2. You have to look in the above diagram, above transition functions, and by looking at that we have to make the, and if you make this enough, and this is the minimized DFSM for the given question. Okay. And this is all for this module. Thanks for watching. See you in the next one.